Hi, everybody. Welcome to our Kubernetes session today. We're going to be covering solving cost and scalability challenges using an AI and autonomous approach. My name's John Jamie. I'm the VP Marketing at Sedai. I've been working in the Kubernetes tool space for nearly 5 years now, and also joined by Pooja Malik, who's a principal engineer at Sedai, who's 100% focused on Kubernetes as well. I'm going to be giving a little bit of introduction to the problem and some of the trends in the market, and Pooja's going to be focusing on the technical side, including providing you with demo of a AI-based autonomous Kubernetes solution today. So we're going to be covering what's new. We're going to be talking about AI and autonomous and how those technologies are coming to the Kubernetes space to help Kubernetes users optimize and run their applications. We'll get into some of the specific challenges that exist for Kubernetes users today around cost and scalability. We'll contrast the AI approach with traditional approaches, and then we'll get into a 5-step methodology for how it applies, in particular in the case of cost optimization, which from the several hundred Kubernetes users that we've surveyed this year, this is kind of the top objective that they are trying to solve right now. Then we'll go into a demo, talk about some use cases, including what is the way that people move from today's optimization approach to an autonomous approach. It's a multi-step approach, and we'll cover that. And then we'll also have time for questions at the end of the session, and we'll also ask for your feedback. We'll be providing a survey link, and would love to get your input and feedback there as well. So just in terms of what's new here, this is really hot off the press news. The technologies we're going to be talking about today, AI and autonomous, have been featured in 5 different Gartner hype cycles over the last basically 18 days. So we feel like the trends we're going to be talking about today are very topical. Gartner is rating these as either high or transformational in terms of their benefits. So we think these are very significant. And we're also excited from a Sedai company point of view. We've been named as a provider on both these categories of technology. So let's get into things a little more. So in terms of what's new with the AI-powered autonomous approach and how does that contrast with how things are done today, there's 3 things that we think are important takeaways here. The first is the shift from a rules-based approach to having AI actually look at your production data and discover what is the best way to configure the application. And we think, why does that matter? Well, we think it's going to give a better solution in terms of cost, performance, and availability, as the AI is basically able to look at many more potential options. Secondly, is the shift from the manual effort involved today in developing these rules, putting together scripts and so on to implement them, to basically shifting to autonomous operations in which the system itself is able to take action on a safe basis in production. The benefits here are faster implementation of the changes, so you're able to capture the gains faster, and then it's also significantly less effort for the operations team as well. And lastly, in terms of the focus, there are many tools that focus today on kind of a single objective, like cost, for example. We think in this new way we're going to be covering today, the idea is really to be able to optimize both cost and performance at the same time, with a awareness of customer experience. So those are 3 things that are shifting. Let's talk about now the AI side of things now. I think everyone's familiar now with how ChatGPT has really taken off and AI is really going mainstream. Developers are now getting a variety of tools, developer co-pilots that are focused on writing, the next line of code for them. It's sort of an LLM approach kind of under the hood to enable that. And what's happening now is that AI is coming to operations as well. So ops teams are going to have access to co-pilots that basically are working with large amounts of operational data and helping the operators basically optimize and manage availability of applications in production. So we think it's an exciting time here. In terms of now from if that was the AI and perspective on AI, if we talk about autonomous now, we think that the need for a system that can operate autonomously, there's 2 macro forces that are driving that. The first is the complexity of microservices, with hundreds or thousands potentially of microservices making up an individual application. This is an example from a few years ago of Uber's architecture. And then the other force that's driving change is the continued acceleration of how quickly new code is being released into production. GitLab here is sharing that 70% of teams are shipping either once a day or every few days. And each year that they survey users, the velocity continues to go up. So we think that Gartner summarized the trend here, the driver towards the need for autonomous in the quote at the bottom here. Manual intervention basically is not sustainable in the long run. So as these trends continue to take hold, so we think that the time is relevant. It's the time we think that teams should be looking at how to introduce autonomous into their operations. We're going to be also covering, what is the bottom line impact today? How do the approaches that we're talking about contribute to, business benefits? Cost, we'll be focusing on costs, as I mentioned earlier. We'll be going in today in terms of three particular contributors. One is optimizing at the workload level, the infrastructure level in terms of the nodes that are used in a Kubernetes application, and lastly, some of the purchase levers. All contribute to potentially 50% plus savings when the approach that we're going to cover today is fully adopted. So let's go to the next slide, please. And at this point, I'd like to hand over to Pooja. Pooja is going to double click into some of the complexities of managing Kubernetes. Over to you, Pooja.
Thanks, John. Hi, everyone. I'm Pooja. I've been working for Sedai from past 1.5 years. I'm one of the Kubernetes nerds here at Sedai. Before joining Sedai, I was with Salesforce, working there for almost 8 years, trying to automate their data centers, their compute, everything. So as John mentioned, cloud waste and operational inefficiencies are significant Kubernetes problems that most of the companies are trying to solve, and they are struggling. So there is a chronic inability to right-size application in complex Kubernetes environments that leads to excessive, ineffective manual tuning or gross over-provisioning or unpredictable performance. So most of our customers, they complain that managing resources in Kubernetes is hard. Actually, Kubernetes itself is complex. People are not really used to declarative approach to configure clusters. So most of them are struggling. So let's see the complexity which is there in managing resources in Kubernetes. So by default, out of the box, Kubernetes provides 5 levers to configure your workloads. 2 facets for CPU, memory and request, 2 facets for memory, request and limits, and a number of replicas. On top of that, you also need to configure the HPA and VPA in order to handle traffic. Then, in order to really effectively use workload optimization, you also need to, Kubernetes also provides, you have to also choose the type of node that you should use for your applications based on your application behavior. So you have to choose the node types. AWS provides 400 plus types of nodes. Then you also need to know how to group all these applications together in one node group and decide on the number of nodes which will be needed. The cluster autoscaler configuration will be needed. On top of that, the cloud providers also gives you option for saving money, for purchase options, saving plans, to decide between spot versus on demand. So you have that also in the mix. And all this has to take care of traffic, which is unpredictable. And also it can change with every release. So you have to consider releases as well. So these are the factors which are responsible for making managing Kubernetes resources at scale hard. Now let's talk about those are the factors. Now let's talk about an example of the scale. So let's say in your cluster, you have 100 heterogeneous microservices. When I say heterogeneous, some can be CPU bound, some can be memory intrinsic, some can be threads or traffic intrinsic. Or some can be custom, which will scale better with the combination of these two. So, and if it's traffic, if it's you have to configure HPA and VPA. And so that adds complexity too. Then but as I said, you also need to know how to configure your HP and VPA, whether CPU, memory, combination of certain metrics, traffic metrics. So that also, let's say there are just 3 metrics using which we are configuring our HP, VPA, and all the other things. Then and again, for simplicity, let's say all these 100 microservices have only 3 traffic patterns, low, typical, high. AWS does provide 400 different type of nodes. So in order to really use your optimize your cluster, you need to also optimize your node types. And let's say for the sake of example, we know that there are only 5 types of nodes which respond good to our applications. Then to add to it, we also let's say most of the companies release once every week. So let's say there are 4 releases every month. So if you see these as combination, you have almost 36,000 combinations to deal with on a monthly basis to make sure your Kubernetes cluster is optimized in the best way. And there are also interdependencies in some settings, like traffic patterns. Now, traffic patterns will respond to vertical scaling only till a certain point, and then you have to go horizontal. So, you should, so that also adds to this complexity a lot. Now, we talked about factors, we talked about scales. Now let's talk about the efficiency challenge that we have in Kubernetes world. So most of the developers are focused on releasing their application to production as soon as possible. So mostly developers guess at resource settings or just use defaults. And configuring these applications to run efficiently on defaults in Kubernetes is extremely difficult. Sometimes we have also seen this task is left on platform teams and without without any knowledge of the application, which makes it even more inefficient and harder. Then because of all the cost optimization efforts in our industry right now, the new mantra is do more with less. But the developers or the people who are managing this are left to choose between reliability and cost. So other than that, we still have a Kubernetes skill gap, which makes these issues even more challenging to be addressed at scale. So because of all these factors, most of the people, they allude to 3 choices. Either have some performance and reliability issues in their applications, which is not acceptable, or do gross over provisioning. That is where our industry is right now. And most of the people, like 40% of the total cloud cost is over provision. Or an acceptable way is spend some time in configuring, time and effort in configuring these resources. But the problem is, so first of all, it will slow down your time to market. Second, it will it's a very genuine problem. It's a very hard problem that we have, that it's very difficult to make the load test as close to production behavior as possible. So, and which our industry is trying to solve. But and then there's a question of cost too, that spending as much in cost for load test as in production is also too much. So and doing this for each release at scale is even harder. So there is so much manual churn involved in this whole load testing process that nobody actually does it. So back at Salesforce, we had a specialized product, but we spent almost close to 6 months in deciding all these configurations for our application. Well, as we say in Sedai, that production is the new playground. So we need to look across the landscape of customers instead of an application in isolation. So going based on observation is much more reliable, scalable, and cost-effective than on load test. So So these are some stats for the over-provisioning problem that we have. So usage data typically says that 30% of requested CPU and requested memory is over-provisioned. And so let's so one of the solution is adopting machine learning for doing optimization. So let's say why we need machine learning, why we need to do machine learning. So one of the most important use cases, there is a slew of data in our existing observation data, and it turns into noise. And so getting effectively using this existing observation data and getting actionable intelligence about our cluster health and operations, machine learning is very useful for that. Then we also want to identify issues before they escalate, and we want to act on them. The root cause analysis, machine learning is also needed for root cause analysis and anomaly detection. And machine learning can also help us do capacity planning and avoid human mistakes. So now let's talk about there are a lot of players in the industry which say they are autonomous. So let's see what is the difference between automation and autonomous. Now, in order to optimize, first you need to identify the opportunities, the optimization opportunities that you have. Then you recommend them. Then you also need to know if your recommendation is correct. Now, most of the systems that are there in market right now, they only do good till recommendation. But after that, all the validation of whether whatever they are recommending is correct or not is not there. And then finally, one of the most important thing is autonomously execute them and then validate again. So this should come out of box from an autonomous system like Sedai. So also in order to also about the process. So an autonomous system should understand what metrics is needed. It should understand the app behavior, how it changes with each release, and it should be able to alter the metrics and the recommendations based on that. Also, the nodes needs to be chosen based on app behavior and ever-changing needs. Also, the autonomous system should give user the control to decide what is their goal, whether they want to decrease cost or increase performance, or they want to do both. Another point here is that so most of the times the remediations that you are doing is mostly a scripted steps. So but it's possible that those scripted steps are not working. Like, for example, if your container is being CPU throttled and you just add more CPU throttle, but the actual cause of the whole issue is your database is not able to handle it and it's processing super slow. So your remediation should be able to understand that, and it should be able to learn and evolve and act correctly. Also, one important point here is that the autonomous system should be able to understand its limitations. So in case if there is, not everything will work all the time, so it should be able to call for manual help. So so this is one of the questions that we get all the time. So when you hear about the word autonomous, Tesla is one of the names that comes up, and they are still struggling with making people believe that autonomous is safe. So and in Kubernetes world, how we make autonomous safe? So obviously scaling down historically can result in cost and performance issues. So our solution, or an autonomous solution, should include multi-level safety checks. So we have ML-powered regression. We have a patented algorithm for intrinsic safety. Our safety governor also makes sure that all the threshold and guardrails in place for every recommendation and every execution we do. We also optimize 24/7. So in case something goes wrong, we can still recover from it as soon as possible. Sorry. Then also we have one very important thing is we have reinforcement learning, which is validating through every step. So let's talk about the approaches which are there in the industry right now in order to solve this issue, these issues. Now, based on most of the companies, they say that I mean, you'll hear a lot of stories where companies will say they can save 30 to 50% off your cost. But what we see is there are mostly 6 types of companies that exist. The APM companies like Datadog and the Insight companies like Cloudability. So these 2 categories, they do give some basic recommendations, which again, you have to act on them. You have to validate them. Other than that, there's nothing else. So doing it at scale, and it's just basic recommendations. So doing this at scale is very, very hard. Then we have few recommendation tools like AWS Cost Optimizer. So this also suffers from the same issues where it gives decent recommendations, but still you have to act on them, and doing that at scale, validating everything at scale is super hard. Then there are companies which go via the HPA and VPA route, self-configured HPA and VPA route too. Now, and there are companies like K8s which do event-based HPA. So actually, I'm not going to talk much about VPA just because I've not seen anybody use VPA in production in execute mode. And I was recently looking at the VPA code, and no, actually it's not being maintained also. So talking about HPA is great because it acts in production, but you still have to know what to configure, which metrics to configure your HPA for. What should be the thresholds? CPU, memory, traffic, combination, there are so many possibilities. Then you also, there's no reinforcement learning. There is no validation of whatever they did is correct or not. So, you don't get a complete solution. There are also some rule-based static optimization tools like KubeCost, which again acts in production, provides recommendation, acts in production, but again, there is no reinforcement learning, so it's a partial solution. It's not a complete solution. And then there are AI-powered autonomous systems like Sedai. So to give you a brief, Sedai uses machine learning to drive intelligent insights from your existing observation data and autonomously right-size Kubernetes clusters at any scale. Sedai uses reinforcement learning, rapid experimentation, and scenario-based analysis to optimize for cost, availability, and performance. So this is the technical approach that we have used for in Sedai. So we hook onto your cloud resources to get topology information. We hook onto your monitoring data to get metrics. And we put all this information into our system, and then we correlate your topology with your metrics. And we use, all this data. We give it to our decision metric, our decision engine, to come up, and then we use the causal AI to do topology traversal. We use DB-scan algorithms for anomaly detection. We do right sizing of workloads using reinforcement learning, right sizing of infrastructure. We also provide you autoscaler configurations and also purchase options. We also do some kind of prediction. We also use predictive AI with drift regression approaches. So we do forecasting, we do anomaly prediction, we do seasonality, we also do predictive scalability for you. And all this, as I mentioned, is based on seasonality and learning models, reinforcement learning engine, safety governor, which makes sure that all your thresholds and guardrails are properly maintained. Then we also have reporting compliance and audit, and all of this is done in a control loop for every release. So one important thing I left is user goals. So user gets to define what is their goal, and based on the user goals only, we'll decide what to do with your cluster. Then so let's talk about the stages of optimization that we do at Sedai. So we first try to right size. We first try to analyze your workloads using your existing observation data for almost 2 weeks. And based on our state-of-art machine learning algorithms and reinforcement learning, we recommend the CPU, memory, number of replicas, HPA, VPA, recommendations for you. And what our customers have seen is 20 to 30% savings just by right sizing their workloads. Then we also try to right size the infrastructure. So in order to effectively use the right sizing of workloads, you have to right size your infrastructure, because your cost is based on that. So we also using our algorithms, we try to come up with the correct node types based on the application behavior. We try to group all these applications together properly in the node group, and we also try to give you cluster autoscaler recommendation. And our customers have seen additional 15 to 25% savings because of right sizing infrastructure. Then we also, since all the cloud providers have a lot of saving options and on-demand versus spot in order to save you money, so we also give you those features where you can additionally you can actually save up to total 72 to 90% savings. And all this is always taking care of the traffic. So we do HPA with combination of both reactive and predictive scaling, so that all the traffic needs are met. And then also we adapt to the new releases. So all this is done in a loop for every release. So there is continuous optimization. So now let's take examples of few of the customer environments. Now this is a very trivial example of just an over-provisioned app, but it's important to demonstrate it. So here it's if you see before and after, the goal here was to lower cost. And we saw that this resource was highly over-provisioned. So we decreased the memory, decreased the CPU, decreased the replica set, and as a result, we were able to bring down the cost by 55%. And then this is a good example where we were able to optimize a resource both for memory, for cost as well as performance. So if you see, what we saw was, this was actually a memory intrinsic app. So we reduced the CPU, we increased the memory, and we decreased the replica set. And we also changed the node type. So as a result, we were able to achieve a latency improvement of 36% and the cost improvement of 48%. So these are the places where Sedai is very, very useful. Where we can do both. We can give you a real optimized cluster. So also, as I mentioned, we do a hybrid approach of doing both predictive and reactive scaling. So the first graph that you see is the 5 days worth of traffic. Now let's see where this the reactive scaling is not useful. Most of the applications, they might have a longer start period, right? So if they have a longer start period, your reactive scaling will not be able to scale the resources as much whenever there is a rapid spike in demand. So that's one of the most important place where you need predictive. We are going to get traffic. Let's spike. Let's increase the pods. Then also it's possible that there were some outages, and then followed by a lot of retries, and you get sudden increase. In those cases also, if you already know, you can use predictive and scale up. And obviously, the variable traffic patterns won't be able to handle it. So predictive scaling is helpful when there are spikes and troughs that sync up with a consistent pattern throughout the day. So something similar to the example that we have shown in the first chart. So what we thought was, if we can come up with a set of algorithms that could predict the capacity needs before there was an actual need. So the second chart, so the second chart that you see is you can see the actual RPS is very similar to what was the predicted RPS that we saw. And the third and the fourth chart that you see is the scheduled scaling action plan, and it closely matches the actual traffic at each step to achieve the best performance. So, but there are definitely going to be spikes and values that we cannot predict, and so in our experience, the two auto scaling systems combined provide a much robust and efficient solution as they complement each other. So these are the examples of, I just want to cover and give you a brief of the path to autonomous that our company uses, because there are times when the customer is not comfortable. So what we are very proud, our initial setup, our whole onboarding takes less than 15 minutes. Then so since it's machine learning, we need to learn from that data. So we put the applications or the cluster in recommendation mode for few weeks, a week or two, and then and once it starts giving a recommendation, we will enable, and we are happy with the recommendations, we will enable autonomous actions on it. And once autonomous actions mostly will be enabled in a dev cluster first, and then after a week or two, once the customer is happy, we will roll it out to production in stages. So these are the example of few of the Sedai customers that we have right now. So let's get into the demo. Let me show you how to create an account and how to add the Kubernetes cluster and connect the monitoring provider. So if you go to sedai.io, right, and click on Start Free, you will see a screen where it will ask you for some basic information of what is your email IDs and your company name and everything. And then after you enter all that thing, I'm already logged in, that's why you don't see that here. You will see a page like this, where it will ask you what is your main goal. Let's say my main goal is cloud cost. I click on Next. We provide all these services, so all the AWS services, as well as any other Kubernetes that you have installed in let's say Azure or somewhere as well. So also we have two kind of solution. One is a complete SaaS solution where you can where you have to open your Kubernetes APIs and give us access. First read access and then write access in order to execute it. And but what we have seen is most of the people were not comfortable with opening the APIs. So we have another solution, which is installing a smart agent in your cluster, which will actually, read the topology and act on our recommendations. So here I select the AWS Elastic Kubernetes service. Then you have to also, since we need metrics, we need your existing observation. You also add the monitoring provider. Let's say for the example, for this example, we have Datadog. Yeah. So there are teams which manage using automated GitOps like Argo CD or something, which can change, which won't allow us to change the settings. So CPU memory replicas. So what we ask most of the people is to disable just those resource settings so that Sedai can control them. So let's say no for now. And here, give your cluster name and how many pods are there in this cluster. So we suggest that you put the exact same cluster name as what is there in your Kubernetes cluster. Then these are the Datadog settings. You give the API key, application key, test connection, and it will take you to a page to launch your Sedai. That's it. You are onboarded. Actually, there's one more step. So let's do that. This, once you click on launch Sedai, it will take you to the launching. So I already have an environment set up, so I'm not going to do that right now. So once after, let's say 5 to 10 minutes, you will receive a mail giving you the URL for your Sedai installation. So if you go to settings, go to integrations, we will give you an option to install your smart agent. We give you both kubectl command as well as a Helm command that you can use and install. So these are the commands using which you can install a smart agent. As soon as you install the smart agent, you will be able to see the resources discovered. Like here in this particular cluster, you saw we have 152 resources. So by default, the resources are set to recommend mode. Now, explaining more about these modes. So it's again, it's the goals and the comfortability of what you want Sedai to do is completely on the customer. It can be controlled both at account level as well as the resource level. So you can very well switch off the recommendations. You can just ask Sedai to recommend. You can also enable them to auto execute. By default, to start with, we start with the recommend. So we'll just recommend you. Other than that, there's also a place to define your goal, again, both at account level as well as at account level as well as at individual resource level. So you can say what is your goal, whether you want to decrease cost, decrease latency, or both. And even for each of these criteria, you can control how much percentage of performance impact or cost impact is allowed. So once you set all this, we will start, after collecting some metrics and doing some learning out of it, we'll start recommending. We generally say 2 weeks of learning is good enough. But the more data you give to the system, it gets better. So we have different type of availability recommendations that we do. We give anomaly detection. We do if the CPU is approaching limit, memory is approaching limit. We give you predictive scaling recommendations. We give so those are availability, and then we give you we can also like all these are basically what we are seeing is the abnormalities. Then if the limits and requests are not set, we also give you that. In order to really efficiently run, don't do defaults, don't do no settings, definitely set an acceptable number. Then after doing some analysis on the existing data and some reinforcement learning, we come up with these reports where we try to optimize your workloads, we try to optimize your nodes, we give you purchase options, etc. So this is one of the example where for one of the cluster, we were able to bring down the savings to 61%. And how we did that was by doing workload optimizations, which is, so we give you the autoscaler configurations, we give you how much CPU, how much memory, that you need to set. And obviously we perform it. So you can also perform these recommendations. So we do have a execute recommendation button if in case it is not, your system is not handled to autonomously execute them. Then we also do all these in stages to make sure, your system is not, your system is responding good to all these changes. And we also give you a spec definition in case you want to directly apply it. So this is about workload. Then we also give you node. We will say, so earlier they were using a M6 A large and an M5 A large. And what we recommended was C6A4 extra large to be used. And we also give you some purchase options, whatever is the most beneficial one. So this is about cluster optimization. Then we also have something called release intelligence. So we also have something called release intelligence. So now this on this page, we give you aggregated view of each cluster as well as individual resource. So this is aggregated view of each cluster, but once you click on this, we'll also tell you for each resource. So here, for example, you can see, you can also change the time to, if you, instead of 14 days, if you want to see past 30 days data, you can also do that. And here we say how many releases happen. According to us, what is the score? So the score goes from minus 10 to plus 10, minus 10 being the worst, the plus 10 being the highest. And also we predict the monthly cost compared to last month or last 14 days in this case. We also compare it, the current latency, the current error, and if there were any SLO breaches. And this is done for each resource. There's a graph saying how many were good, bad, and worse for each day, and also for each resource, how it did. Other than that, there's one more thing that I think I'll get into, which is individual resource optimization. So what you saw was the workload optimization. It was not based on experimentation and not based on full reinforcement learning. So this is the place where we will do an extensive reinforcement learning and rapid experimentation, and we'll try to come up with the best possible optimizations for you. So for example, if we see this app, the goal, sorry. So the goal for this application was decrease duration. And what we did here was we increased the CPU. So there's we slightly increased the CPU, and as a result, other than that, no change everywhere. And as a result, we were able to bring the latency down. And also, I mean, again, there's a slight increase in the cost, in the cost, but that was acceptable. Another such example where we were able to actually decrease both cost and actually this is just decrease cost. So we were able to bring down the cost by just changing the memory. I'll just show you an example where we were able to do both. So for example, if you see this example, we what we did was we just okay, this is a good example, very similar to the example that I showed in my slide earlier. So here the goal was both decrease cost and cost and duration, and we were able to so what we were able to increase the CPU a little bit and change the replica set, and as a result we were able to decrease the latency and also cost, improve performance and cost. So I think that's pretty much it for the demo. John, do you want to take over? That's
Yes, thanks, Pooja. That's a pretty awesome awesome set of technology to kind of walk through. So thanks for that. Thanks for the demo there. Now we've got about 12 minutes left, and a couple of things that we wanted to cover. If you would like to share your questions in the chat, whether that's on however you're watching us today, and we'll have a chance to answer them here. And then also while we do the Q&A session, please take a minute to take our feedback survey. We'll put the link in the chat here, but it's sedai.io/K8s. Please take a minute to fill out that survey. We would love to hear your thoughts on what we've covered today, and we'll also give one person who takes the survey a Star Wars Lego set. We've got the Millennium Falcon one in the corner there, which is a pretty neat set. So I'll look at some of the questions here. We had one earlier. Can we get the Gartner reports that were mentioned? The Gartner reports are shared with the Gartner subscribers. If you email us, email me at john@sedai.io, I can share with you the links to all the individual reports. We did share a screenshot there of some of the public research, which was the SRE hype cycle. Yes, and okay, we see Kumar here is, I think, about to write a question for us. Yeah, just please feel free, Kumar, just finish your question there and we can cover that. I'll look for another one in the interim. A question for you, Pooja. Do we get interim recommendations from Sedai during the first 2 weeks? So I guess after setup, while the learning takes place, could you give us some insight on that?
Yes, we do. But as you know, how machine learning really works is you have to give it time to learn. So we will give you recommendations, yes, but it won't be as good recommendations as when once we have observed your system for at least 2 weeks. So we prefer people waiting for 2 weeks, but we can relax our settings to give you recommendations even before. Yes.
Okay, got it. We had one more here. If someone has different Kubernetes integrations like Kida and Carpenter, and maybe even kind of other auto scaling tools, sort of how does Sedai work with that? I think you touched a little bit on that, but maybe if someone is using a lot of integrations, how would it work?
Yeah. So yes, we identify what kind of cluster autoscaler or application autoscaler you are using, and we do integrate with both K8s and Carpenter. Yes.
Okay, got it. Last one here. How do the safety checks work? Obviously, people are using autonomous systems is new for many people, and so people really want to understand the question here and be confident.
Yes. So definitely, this is a question we get a lot, because autonomous is something that people are still getting comfortable with. So so first thing is we have ML regression. So we we make sure your all of your data is analyzed based on all this ML algorithms, and make sure it is whatever we are optimizing is correct or not. The second thing is we have state of we have a patented solution here. We have a patented way of improving our reinforcement learning, where we have a way where we make sure that reinforcement learning is safe. Third is we have a safety governor where we make sure all your guardrails and thresholds are maintained. We will never, let's say, decrease something by 70%, 60%. So we have all these guardrails and thresholds in place to make sure we are not doing crazy amount of optimization. Those optimization can be handled in the second optimization cycle, because we are doing it continuously, right? So we don't have to be really aggressive. We try to be a little submissive with respect to optimization. Then we also make sure whether your cluster has that kind of capacity or not, how to increase. So those kind of guardrails are also in place in checking your node capacity, your cluster capacity, all those things. Then also, well, we optimize 24/7. So in case something goes wrong, we can still very easily within 10 to 15 minutes recover from it. So that's why we proudly say we are a autonomous system which is safe.
Okay, so I think it's sort of a multi-layered approach to production safety, I think.
Yes, correct.
And I think, probably perhaps also worth mentioning, so Sedai's founders had been working at PayPal on an autonomous system there, which was doing 2 million autonomous remediations a year. And I think it was the only one of the only systems trusted to sort of make changes in production at the peak. So they have some experience in sort of large scale environments and operating there as well. So I'm sure Pooja, you do as well from Salesforce side. So yep. Okay, let me check if there's any kind of final any last questions here. Perhaps Pooja, last one here. We've focused a lot on sort of cost today as the use case. If someone is wanting to focus on performance or performance for certain elements, certain parts of their application, sort of how would that work?
Again, we, at least specifically for performance, we need data from you for at least 2 weeks. Once we have the monitoring provider data, we have reinforcement learning, we have rapid experimentation to exactly say what configuration works best for you. So we do all that, and we come up with the correct, most optimized configuration for you.
Got it. Great. All right. I think it's all the Q&A that we've had so far. In terms of next steps, please complete the feedback survey if you didn't yet. Otherwise, you can learn more at sedai.io. You can just start free. Pooja was sharing, it's very simple to just get up and running. To try it out, and we welcome your feedback and look forward to going on this autonomous journey that the industry is going to be going over the next 2 years. So So thank you very much for everyone attending, and feel free to reach out with your questions. Hope you have a great rest of the day and great weekend. So thanks so much, everybody.